Well, here we have a difficult trigonometry question. It's got find the definite integral from 0 to 1 of x squared over square root of 4 minus x squared with respect to x. Well, what I'd like you to realize is because we've got this 4 minus x squared underneath under a square root sign, we want our objective to be, let's change the color of that because it's hard to see. We want our objective to be, if we can get a 4 minus 4 sine squared theta, not x, no longer x, but if we change x around to theta, we can get that 4 to be factorized to be 1 minus sine squared x, and then eventually under the square root sign, because it's on the denominator, we can have a 1 times, and replacing 1 minus sine squared x, that would become cos squared x, cos squared theta. That's our objective. So let's substitute our x and replace x with, now to get a 4 sine squared theta, we need that to be a 2 sine theta. Well, that's our first hurdle, to know to replace the x with 2 sine theta. This is going to help us, so let's see what will happen. However, notice we've got all these x values here. We've got an x there, we've got an x there, and this is an x value, and this is an x value, that's x equals 1. And what we have to do is replace all of those values in terms of theta. So what we do is we'll get the derivative, dx d theta, and the derivative of 2 sine theta is 2 cos theta. Now, if I take that d theta up to the other side, dx equals 2 cos theta d theta. So what we're going to do is replace dx with 2 cos theta d theta, and replace that x with 2 sine theta, and then it'll be squared. Replace that x with 2 sine theta. We need to replace this 0x. All right, well, let's just say if x equals 0, what will theta be? X equals 2 sine theta. So 0 equals 2 sine theta. All right, so for 0 to be sine theta, theta has to be 0 radians. We're going to be talking in terms of radians. And that's going to be, we'll replace that with a theta value of 0. And if x is 1, 1 equals 2 sine theta, half equals sine of theta. All right, for sine of theta to be half, since we know that sine of 30 degrees or sine of pi over 6 radians equals a half, therefore our theta value is going to be pi over 6. So we'll replace that with a theta value of pi over 6. Okay, let's rewrite it. 0 radians, pi over 6 theta. X is 2 sine of theta. We square that. 4 minus, and x is 2 sine of theta. We square that. And d theta, dx is going to be this here, which is 2 cos theta d theta. All right. Second obstacle crossed. Okay, our first obstacle was to know that x has to be 2 sine theta. Our second obstacle was to replace all the components, change x out in terms of d theta. Now let's work on this. Let's work on this one here. And we've got from 0 to pi on 6. Now that's 4 sine squared theta. That's the numerator. The denominator, as we knew would be, we were wanting it to be, that's the way we designed it, 4 minus 4 sine squared theta. Good, that's what we want. Why do we want that? Well, our 4 will factorize, so I'll just leave the 4 sine squared theta on the numerator, and that's going to be 4. Well, outside of 1 minus sine squared theta, 2 cos theta d theta. Now this is where we replace our 1 minus sine theta because, as you know, sine squared theta plus cos squared theta equals 1. Cos squared theta equals 1 minus sine theta. 1 minus sine squared theta. So we're replacing 1 minus sine squared theta with cos squared theta. So let's do that. 0 pi over 6 on the numerator. We still have, now we've got square root of 4. Well, I just change that to 2 and leave that as 1 minus, well, actually, that's not what I was wanting to do. Let's just do what I said I would do. I'm going to replace that with cos squared theta. Yeah, that's what I wanted to do. 2 cos theta d theta. Now the square root of 4 is 2. The square root of cos squared theta is cos theta. So let's just leave our 4 sine squared theta on at the top. The square root of 4 is 2. And the square root of cos squared theta is cos theta. 2 cos theta. Well, look at that. Now you can see that it's working in our advantage because 2 cos theta cancels with 2 cos theta. And we're left with a simpler expression. 0 pi and 6. We're left with 4 sine squared theta that's right, yep. Let's put d theta here. All right, now the thing here is we're going to get the integral of sine squared theta. Now I just want to look at this sine squared theta, and there is an easy way to do the integral of sine squared theta, and that's knowing that, let's put something in black over here. That's knowing that, do you remember cos 2 theta equals 1 minus 2 sine squared theta? Are you familiar with that? That's kind of an important concept that we have to realize, because we're going to use this equation to change the square into a trig with no squares. So if I just rearrange this, I'll bring the 2 sine squared theta over, take that cos 2 theta over to be 1 minus cos 2 theta, and then sine squared theta is 1 minus cos 2 theta over 2. And I'm going to replace sine squared theta with, oh, okay, we've suddenly changed to black. 4, change sine squared theta into 1 minus cos 2 theta. We're almost finished now, over 2, because you can cancel that to be a 2. And then we've got, expand that, 2 minus 2 cos 2 theta. Now the integral of 2 is 2 theta. Actually, I'm going to do the integral here, so I won't be able to put that there. I'm actually now doing the integral. The integral of 2 is 2 theta. And the integral of cos 2 theta is sine 2 theta. And we want that to be the integral of sine 2 theta. And then you divide by the derivative of that bracket. And then because it's a definite integral, we don't put plus c. We just say we're going to integrate that from 0 to pi and 6. So we have to now substitute. And we're almost finished. I've not been putting these in. Substitute pi and 6. So 2 times pi and 6 is pi and 3. and that 2 cancels. And we've got sine of double pi on 6 is pi on 3. And then you substitute 0. 2 times 0 is 0, minus sine of 0 is 0. Okay, that's just 0. And we finish by just replacing sine of pi on 3 is root 3 on 2. You should know that by sine of 30 degrees is a half. Sine of 60 degrees, which is in fact pi on 3 radians, is root 3 on 2. And I get that from, do you remember that equilateral triangle, a 2, a 2, a 2, cut it into half, you get a 1, root 3, that's a 60, that's a 30. Sine of 30 is opposite over hypotenuse. Sine of 60 is opposite over hypotenuse, which is root 3 over 2. And we're finished. I hope this has helped. Until next time, stay happy.